Yes, start with learning or programming. So learning any programming language, it's just like learning any natural language. So maybe that natural language may be English, German, or Hindi. So let's say if someone wants to learn English, so that person has to learn first what are the alphabets that allowed in English language. And once you covered all the alphabets, then you have to group those alphabets in order to form a words. So once you group those alphabets, you are going to have two categories of words. One is dictionary word, means for those category of words, the meaning is fixed, already defined inside dictionary. So those words cannot be used for other purposes. Second category of words that are user defined words. So as a human being, we can use those words, for naming the person's name, for example, John, Mohan. So for those category of words, there is no fixed uh, English word defined inside dictionary. Then once someone learns how to form a word, then that person has to learn sentences. So sentences is nothing but grouping of words. And once a person learns sentences, that person can group those sentences and form the paragraph. So now compare those steps with learning R programming steps. So obviously R is again a one language. So we have to learn what are the alphabets, what are the digits, what are the symbols that are allowed inside our programming environment. And once we learn all those things, then we will go to one step ahead by grouping those alphabets, digits, special symbols with one another, or maybe grouping alphabets with self grouping alphabets. So we are going to have constants, variables, keywords. So variable is similar to that what we have seen in case of person name in natural language. So I have just mapped here is variable name is with this person names. So these names going to be used by uh, programmers for giving user defined names, and these are the keywords for which meaning is already defined. The way we have learned some words in English for which dictionary meaning is defined, in the same way there are some words called as keywords inside any programming language for which the meaning is fixed. We cannot use those keywords for naming any variables. And once we learn grouping of alphabet, digital symbols, then we have to form an instruction. Instruction is nothing but grouping of those variables, keywords, constant. And once someone learn how to write an instruction, that person can write also a program, because program is nothing but basically grouping of some instruction. So what are the alphabets that allowed in R programming? So you can see a capital A, capital B, and so on up to capital Z, then small a, small b up to Z. Then digits are 0 to 9, they are allowed. Special symbols like a dot, then dash, etc. are allowed. So now rules for constructing variable name. So these are the some rules we have to follow in order to define a variable name. For example, a variable name can contain letter, number, and underline character. And sometimes you can start with dot as well. The variable name can start with letter or digit. If variable name start with dot, then we have to take some cares. Once we decided the variable name going to start with dot, the dot should not be followed by a number. In any condition, the variable name should not start with digit or by underline character. So from those rules, it is very much clear. The variable name going to start either with letter or with dot. If we decide to start the variable name with dot, then we have to take care that dot should not be followed by any digit. So in any case, the point number 4, in any case, the variable name should not going to be start with digit or underline character. If we do so, then our environment going to generate an error. Let's move to the third slide. Yes, so these are some example valid variable names. For example, where underscore name to dot where underscore name where name. So these are some variable names because we have followed the rules. And some of the invalid variable names are here, where underscore name percentage. So percentage here is a special character, and as we discussed in the last slide, there are some characters that are allowed. So percentage is a character that is not allowed inside our environment. So obviously, if we try to define some variable name with the percent, it's going to throw an error. Second is to variable underscore name. So here the name start with digits, and as per the rules, name should not be start with digits. So again, an error. Third point, if any name is start with dot, then should not be followed by a digit. So that's why error. So we have to take some care when we try to define the variable name. We have to follow the certain rules and regulations that defined by our environment. Now our keywords. As I discussed with you, these are the words for which meaning has been defined in our environment, and these keywords cannot be used for naming the variables. We have to take some cares for that. So for example, if it's already defined inside the R dictionary, while it's again defined in the R programming dictionary for etc. So we cannot use those keywords for naming the variables. Now come to the data types in R. So as far as data types in R is concerned, the data types. So first of all, what are the data types? Data types in R, basically we can define into 5 categories. So these are character, numeric, then integer, then complex, and then logical. So first of all, before going into detail of these things, first we need to understand what do you mean by data types. Data types is nothing but basically it tells us what types of operation we can perform on the data, on the value. So if we know the type of data, then obviously we can also define the valid operation associated with that data type. For example, if data type is corrected, then obviously we cannot do multiplication division type operation, because we know multiplication division type operation is defined for numeric or integer types or complex type, but it's not defined with character types. So let's see all data types with our examples instruction in R Studio. So let's open the R Studio. So I'm going to open the R Studio. Yes, so you can see here the heading is variable and data types in R. So as I explained to you, variable name can contain letters, underscore, digit, or dot. A variable name must start with a letter, or sometimes you can start with dot. If it is start with dot, then dot should not followed by a number. That is, you have to remember all the time. It cannot contain dash and other special characters like dollar, hash, percentage, ampersand, etc. Now, this is very important. In R, we can use the equal sign to assign values to the variables. And however, there's another operator that can be used to assign the values to the variable, either this or this. So the important thing is, when we using this either this arrow or this arrow, then the arrow must be directed towards the variable names. So what does mean it? Let's go through this. So first of all, we have defined the variable x, and x is going to follow these rules. So the rule is it should start with letters underscores, digits, or dot. Obviously, it's not going to start with underscore. So here in this case, it's starting with alphabet, letters. So this is valid. So here what we are saying, just assign 5 to x. And in the next line, we are assigning 7 to y. You see the direction of the arrow towards the variable. So both essentially means same thing, representing the same thing. So once we assign these variable, we can execute this. Then once again, we can execute this. Now we can perform some operation as well, x plus y. So this is going to be a 12. You can see here the output. And then once again, then we can perform the subtraction operation. You can see here x minus y going to be a -2 because x was 5 and y was assigned value 7. Then x into y we can perform. So x is 5, y is 7, so going to be 35. We can execute this. So we can, this is division, this is again a division, and this is x raised to y. So x is 5 here and y is 7 here, so 5 raised to 7. So this is going to be a 78125. We can store the result of these operation into another variable. So let's say we want to store the result of the operation x plus y. So this is the way we can store the result. So by this instruction essentially means we are telling to our environment, please store the result of x plus y operation into variable z. So once we execute this, the expression x plus y going to be evaluated and the value of this expression going to be stored in the variable z. We can check it by running printing this z. So just either use print statement or just typing the variable name by which we can print the value of z over the console over here. In the same way, we can store the result of this expression into y, and finally we can print the value of y. So y, so we can print the value of so here basically by mistake. Now it will run. Yes. So w going to be a 35. Okay. So now comes to the data type, that what we have discussed over here. So these are the data types: character, numeric, integer, complex, and logical. These are some basic data types supported in R. So we are going to discuss each data types by having one example in R environment. So starting with character. So with data types, two things are associated with the class and type. So class is nothing but it represents the abstract type of the object, and type is nothing but basically representing, is giving the information how that particular variable going to store inside the computer memory. So things will clear when we go to the actual code. So let's start defining the character type. So here, this is the definition. We can define character by using a single quote and values, writing some value inside this single quote or writing values inside double quote. So both are same thing. So for example, I have here declared the variable x1. You can see here the variable is starting with alphabet then followed by digit. This is perfectly valid. So here inside this string I have, okay, this is a string inside double quotes. So once going to execute this first line, so this is x1 going to define with value dp sharma. So what is the class of x1, what is the type of x1? So this is going to be a character, class is character and is stored as a character. Okay, so this is example that we have seen just now with double quotes. Same can be done with the single quotes. You can see here again in this line number 42, 44, basically we are defining variable x2 with the dp sharma, and see the class of x2 is character and class of and type of x2 is again character. Now consider, this is very important example. It looks like a number, but when we write a number inside a double quote or single quote, that number is no more a number, it's going to be behave as a string. So that's why when you are going to execute this, so x3 going to define with the value 145, this is again a string. So these things can be cross-checked over here when we try to run the class of this number. The class is going to be a character, you can see, although looks like a number, but class is a character because we have store the number inside the double quotes. Then again, type of the character in memory also it's going to store as a character. So this is all about character types. Now come to this number type. So in number, so in number there are two category of numbers are there. So we have to look in two category of number. So number can be a decimal point number or without decimal point number. So you can say here like this. So let me just start the annotation. Let me start this annotation over here. So number can be a two types. One is, so I'm going to write over here. So number can be a real number, that is number with decimal point. And another category number is integer. So there are two categories of numbers that are also allowed in case of R, but by default, the number going to be treated in R environment is nothing but basically float. Some in programming language, real number are called as a float. So by default, all the number may be defined as an integer. By default, is going to treat it as a float. So for example, here in line number 55, I have defined n is equal to 53. So just a minute. Here n is equal to 50, n is equal to 3. So now class of n is, so first let me run this. So n is equal to 3 is defined. Now class of n, you can see here, this is going to be a, sorry, just a minute, class, just a minute, some problem is there. Just a minute. So you can see class of n, when we run this is numeric. When we check the type of n is again a numeric. So sorry, type of n is going to be double because inside computer memory the float number is going to store as a double, and when you print the value of n is going to be a 3. You can see here our intention, in fact we have defined 3 as an integer, but by default it is going to treat as a float. This is our fundamental property that is defined by our developer. So any number that you might have defined as a integer or as a float is always going to be treated as a float. So that you can see from the line number 50 to 58. I am going to show you once again. In fact, first clear this so that the things will be clear. Now once again run this. So n is equal to 3. The class of n is equal to numeric, although it looks like an integer, but it's again a numeric. So numeric here is float, and type of n is double. Now come to the integer. So then how we can work on integer? Let's say we want to work on integer. So in that case, you have to append this L, capital L with the number, then are going to treat it as an integer. So you can see here, let's say n is equal to, when we run this, so n is going to be 3L, and when we check the class of n is going to be an integer, no more numeric now, integer. This is because we have forcefully changed the behavior of default behavior of float to integer by adding this capital L. Now see the type of n is again going to be integers, no more double. So please be take care when we talk about float going to be stored inside the computer memory as a double, and integer number going to store as a number. So this is, and this print is as usual. Now come to the complex data type. When we talk about complex data type, it just looks like normal mathematical things over here. We can define complex by just a real number plus some imaginary part. So this is 3 plus 4i is a complex type. We have defined this number and the value is assigned to variable z. So when we check the class of z is going to be complex, type of again going to be complex. You can see here. So class of z is going to be complex. The type of z is going to be complex. Now come to another type of data type that is called logical. So logical variables can take two values, true or false. So here I have assigned m is equal to true and n is equal to false. So see, I have assigned these values, m is equal to true, m is equal to false, and take care The true is all are capital, nothing is small. Here false is all are capital, nothing is small. So now let's say we check the class of M, that going to be a logical, and we going to type of M, this again going to be a logical. So this is logical. Now, but very interesting thing, internally inside computer memory, the value true always going to interpret it as 1, and the value false is going to interpret it as a 0. So obviously, if this is the case, then we can perform all the operation m plus n. So m is going to 1 and n is going to be a 0. So we can perform this 1. M plus m is going to be a 2. We can check it. M into n is going to be a 0. We can check it. N divided by m, n is 0 and m is 1, so this is going to be a 0, and this is going to be a m divided by n is 1 divided by 0 is infinity. So you can check over here. So internally thumb rule is what, all logical values maybe in printing print something different, but internally it's stored as a 1 and 0. True means 1, false as a 0. So once this is true, then we can perform all the mathematical operation over here. This is very important thing. The variable names are key sensitive. So let's say if we have defined capital C is equal to 100. See, capital C is equal to 100, and we try to print, small c. Capital C is 100. That learn by this. You can see over here. When we, that execute capital C. So here you can see a capital C is equal to 100. When we try to print by small c, it will generate an error. In fact, it's not error, C is something else. So let's say just change with this capital B, and let's print with B. So it's going to generate an error. So let's say once again B is equal to, run this. Just a minute, B is run this. So learn by the environment. When we try to execute this B, is going to generate an error, because that small b and capital B now no more same thing. These are representing two different things. That's why case sensitive. We have to take care when we define the variable name something else. So if we define with the capital letters and we define the small letters, those are going to be a different ball game together altogether. So we have to take care. One more example. So we have seen print statement with the small p. If we try do so with capital, starting with capital P, it's going to give an error. So this is error you can see over here. So if we change this p with small p, then it's going to be run as a normal function. It will print hello. You can see over here, hello is getting printed over here. So this is all about all the data types. Now we can convert one data type into another data type. For example, so let's say in this case, what we are trying to see, this converting one type to another using function. This is a function as dot target data type and value. So for example, in line number 103, we are saying, please convert x3 value into integer. What was x3? We can check over here. What was x3? CLASS class x3. So it's a character. And what was the value of x3? You can see here value was 145, but it's in double quote. So obviously originally it was a number, when but now in this case it's defined as a character. So we can convert this character into a number, into an integer. So obviously when we run this command, so obviously when we run this command, we are going to convert this value into 145. See, so now no more double quotes. So this number is going to be a integer number. And once again, by this executing this once again, this x3 was originally character, is going to convert into a number. Now see this example. 1 is a number. We are trying to convert into logical things. So as dot logical, when we are going to execute, it will going to produce true. True, because 1 corresponding to true. Let's say if it is 0, then it's going to be produce false. Now see, come to this table, environment tab. Inside you can see lot of variables that has been defined by our program. So let's say consider a situation where we are working on a large size program where we have defined so many variables, and obviously when there are lot of variables defined, we might forget some of the variable. So if we want to check what are the variables defined inside this program, current program, we can use this command ls, and this curly braces for function. So when we run this, it's going to be produce this list. These are the variable currently defined in our environment. You can see here b, then c, then m, and then n, up to z. So everything is. Now if you want to remove a variable from the environment, this environment, for example, if you want to remove x, this is x, you can just executing this. You can see here when we run this x not going to be x is now there is no more x. In the same way, let's say if we remove this x1 is dp Sharma, we can remove this. So once again, when we run this, no more x1. In the same way, if we want to remove more than one variable, just rmn and then variable name, one variable name, then comma, then followed by another variable name. By this, we can do it. Or we want to remove all the variables, then you have to use the syntax rm within this list is equal to ls, and it's going to be remove all the variables. So now you can see here, this is empty. Thank you. So this is all about what I want to cover in case of data types and variables in R. Thank you.